So let's continue with the instrumentation amplifier. Let's call it as an IA. Okay, so what we have here, it consists of 3 operational amplifiers. Right over here, we see here. Let's call it as an operational amplifier 1A1, which has a gain A1. This block has gain A2. This block has gain A3. Or let's say these are the op-amp 1, op-amp 2, and op-amp 3. And what we had here in the previous configuration, so this completes our circuitry, right? And this node was X. So in the previous module, we can recall that this advantage of this complete circuit was advantages, a high input resistance. That is Ri, ideally infinite, and this is because of these additional blocks that we added before the signal reaches to this third amplifier, which is the differential amplifier. So what happens with these are the voltage followers, non-inverting configurations. They act as a buffer between input signals and the differential amplifiers. Okay, without them, if we directly apply the signals right at these 2 nodes, so we know that the differential input resistance is set by 2 times this resistor. Okay, that is 2 times R3. So which is higher, and also the problem was that R4 over R3 is the gain of the resistor. Let's write here. For the differential amplifier, we know that RID was given as 2 times R, which is, if it is R3 here, then it is R3. And the gain AID is the ratio of R4 over R3. So if we try to increase the gain, we can increase the R4 or we can reduce the R3. So if you reduce the R3, RID also goes down. So that's the drawback. So that's why we put these 2 buffers here that will provide the high input impedance to the input signals that we apply. So the second advantage was the higher gain. So we know that the total gain of this circuitry or total gain of this instrumentation amplifier, which was given as VO is equal to R4 over R3. That is the gain factor by this differential amplifier multiplied by 1 plus R2 over R1. So that's the gain set by these 2 amplifiers multiplied by VID. Okay, right over here. So let's write. So we can write here the gain, that is AID, that is R4 over R3, 1 plus R2 over R1. Okay, that's the gain. But what was the drawback? Drawback was, which is the disadvantage. Disadvantages is that the common mode signal, that is, let's say we have a signal common to both of the inputs. So these two first stages, A1 and A2, they amplify that signal. So for instance, A1 amplifies this signal, and this signal then passes through this differential amplifier. So differential amplifier also has to deal with this common mode signal that got amplified in the first stage, along with the differential signal that we see here, right? Okay, so that's the problem. So what we can do here, so problem is that common mode signal gets amplified, or let's say CMRR, common mode rejection ratio, is relatively higher. Okay, higher. Second condition is that there has to be a matching, proper matching between the two signal paths. That's, let's say, path 1, and this is path 2. So these resistors in each of the signal paths has to be matching. If there is any mismatch, the output, it gets reflected by unwanted signal in the output, and that gets amplified by the gain set by these two stages right over here. So that's the second problem that we have right here. Okay, so these three problems, can be solved by means of simple modification into the circuit. We see that what we do here, we just, instead of R1 in each of these branches, we can do simple modification where we have this resistor, we just remove the ground, and we say that this combined resistance is the addition of the two resistances that we have. Okay, and this signal is applied in the same way right over here. Okay, so how to analyze this circuit and how it will solve our problem, we'll see that. So let's first understand, this is the signal right over here, that is V1 and that is V2. Okay, so V1 is Vi2, and because of the virtual short concept, the signal that reaches at this node is Vi2. Okay, so V2 is Vi2. Similarly, we know that this is V1 and that is V2. Okay, so V1 is Vi1, and that signal, because of the virtual short, comes over here. So V2 is nothing but Vi1. So the voltage difference between the two signal is Vi2 minus V1 right over here. So we see that the current that flows through the resistors is the current, which is the VID, which is the differential voltage divided by 2 times R. That's the current. This current flows through this resistor. It develops the voltage VO1 here. Okay, and similarly, we see that this current that flows through the resistor is the same. Okay, so the current flowing through 2R1, the current flowing through R2 right over here, and current flowing through R2 right over here is nothing but VID over 2R1. So, okay, and the voltage that gets developed at this terminal is VO2. Okay, what we have here is VID is nothing but VO2 minus VO1. Finally, we can write there, we know that VO1 is 1 plus R2 over R1 VI1, VO2 is 1 plus R2 over R1 VI2. So VO2 minus VO1 is 1 plus R2 over R1 VID. Okay, and final output right over here. Okay, that is the gain of the differential amplifier R4 over R3 times VID is nothing but now this one, what we see here. So 1 plus R2 over R1 times VID. So this is the combined amplification. So gain is set by this ratio of these resistors. So we know that this is the final expression in the case of amplifier, instrumentation amplifier. But the problem here now we see that how does it solve the common mode signal problem that we've seen in the previous module. So for instance, we know that let's say we have a common mode signal that comes over here and that comes over here. Okay, that's the common mode signal. So VIC. So let's say VCM, that is common mode signal, and that is applied to both of these inputs of this amplifier. So what we see here, because of the virtual ground, this voltage at this node is VCM, and the voltage, because of the voltage virtual ground concept, voltage at this node is again the VCM. Okay, so the voltage difference between across this resistor is 0. Okay, so there is no current. So the current through the resistor due to common mode signal is 0. So we see that. So there is no current through the resistor. It acts as a open circuit, and this common mode signal appears across the inputs. That is VO1 is nothing but 1 plus R2 over, not really. So this VO1 is nothing but VCM, okay, because we know that it is now acting as a buffer. And we see here VO2 is also VCM. Okay, so the VCM comes here, and because of the differential amplifier of this third stage, which is a differential amplifier, the common mode signal is 0. Okay, ideally, because we know that it will reject any signal common to its terminal. So that's how it will work. So that's the story of the instrumentation amplifier. So we continue with this.